My name is Abby Saul, and this is my presentation on stability and thermostability of mRNA vaccines for COVID-19. So this is the process for manufacturing mRNA LNP vaccines. First, we extract DNA and then we sequence it to get the protein of interest, the sequence of interest. Then it becomes an mRNA product, which is then going to be encapsulated into an LNP formulation, which is basically the particle it's going to be in. And then it goes into fill finish inside like bottles and how it's going to be stored. And then it goes into analytical platforms to be analyzed for quality and then make sure everything is right for the conservation. Here's a little bit of background on what mRNA and LNP looks like. So on the left, there is the mRNA structure, which is composed of the coding sequence in yellow here in the middle, which is basically where all the nucleotides are, and this is what's going to be translated in the body as proteins. Then we have the untranslated regions, which are in blue on the image, and these are nucleotides that are not going to be translated, but help in stabilizing the mRNA. On the right side, this is the LNP structure, and LNP stands for lipid nanoparticles, which is what encapsulates the mRNA. It's made of four kinds of lipids. There are the ionizable cationic lipids, which help stabilize the nucleic acid and prevents the degradation, because mRNA is very sensitive to RNase, which is an enzyme that's very common in the body and in the environment. We also have the lipid-anchored PEG lipids, which are mainly called just PEG lipids, and those are basically the backbone of the LNPs. It's kind of like the proteins in the body, how they make up the structure. The PEG lipids also make up the structure, and it helps make it more available in the body. Why is this topic important at all? During the COVID, we can see that the vaccines were not available everywhere, and that's mainly because the vaccine are required to be kept in ultra cold conditions, so -60 to -80 degrees Celsius. That is very low. Usually you keep vaccines in 4-degree or like -20-degree freezers. And so having this requirement of being in this low temperature makes it inaccessible in all the parts of the world. So developing countries or middle income countries not necessarily have access to those kind of storage conditions. Also, because we're keeping it in such cold conditions, the LNP structure can be affected. So because you're freezing them and then you're thawing them, the particle size can increase and decrease, and the particles can get glued together, which is particle aggregation. We can also see ice crystals in the LNP structure. And because also all these changes are occurring to the LNP, it also reduces the efficacy of the mRNA, and it can be released earlier, which is not what we want. We want it to be able to be released progressively to have time to develop properly in the body. So how can we address this? This can be addressed in several different ways. You can do it by looking at the mRNA structure and modifying that. So we can add an N1-methylpseudouridine to this sequence that helps it increase in translation. We can also increase the PEG lipid content. Like I mentioned, they are the core of the LNPs. So by increasing them, we're making them more sturdy and durable. And then the addition of cryoprotectants. So cryoprotectants are substances that are added to a product to make them last in cold chains. And so here, for example, for Pfizer and Moderna vaccines, they have added sucrose, which is basically sugar. So a lot of sugars are added as cryoprotectants. There's maltose and mannitol that are also added. Another way to freeze them is to freeze dry them. So while you're removing the water, it helps avoid hydrolysis of the mRNA and keep the particles a little more stable. So this is my work from a summer on how to improve and optimize mRNA vaccines. He was looking at how to improve encapsulation efficiency depending on the buffer and the cryoprotectant that you use. I use the buffer, the tris buffer, and then 5% trehalose, which is the cryoprotectant. It's a type of sugar that helped, I added to the LNP formulation. And so the purple line is in a 4-degree fridge. The -20 is the blue line, and then the -80 is the green line. And so we can see that there's a drastic change in the encapsulation efficiency in the -80-degree freezer, which is what it's kept in right now. So from this, we can clearly tell that it does not hold well in the -80, and it's preferred if we could find a solution to keep them in the 4-degree fridge.
So my name is Elena Parker, and today I will be talking about the relationship between food insecurity and chronic illness. To start off, food insecurity is a very prevalent issue that disproportionately affects low-income and minority communities. The National Institute on Minority Health and Health Disparities defines food insecurity and nutrition security as consistent access, availability, and affordability of foods and beverages that promote well-being, prevent disease, and if needed, treat disease. When these conditions are not met, a person experiences food insecurity. Food insecurity can be caused or enhanced or exacerbated by a number of socioeconomic factors such as poverty, race, and health education. Here in North Carolina, an estimated 1.5 million people face food insecurity. Recent studies highlight the links between chronic illness such as diabetes, hypertension, atherosclerosis, and obesity to food insecurity. So a study done by the U.S. Department of Agriculture found that food insecurity increases one's chances of developing diet-related chronic illness. Finances and race play an extremely influential role in determining one's food security. Unfortunately, fast food is incredibly convenient and accessible in low-income communities compared to high-quality, nutrient-dense foods. After noticing that health disparities and obesity-related diseases existed in Black and low-income communities, a group of Harvard researchers set out to discover the reason why. The study found that Black communities had higher access to fast food, and with increased poverty levels. Oftentimes, fast food is the only option for many families due to its affordability and convenience. But fast food is generally high in calories, sodium, cholesterol, and fat. Long-term and frequent consumption of unhealthy foods with these characteristics directly contribute to the development of diet-related chronic illnesses like obesity, type 2 diabetes, high blood pressure, and cholesterol. An additional barrier to food security is the lack of nutritional education. Some people aren't even aware of the negative effects fast food and the positive effects that healthy foods have on their overall health. When people are used to following a certain diet their whole lives, it's very difficult to change their eating patterns in adulthood. It's critical that people learn how to incorporate a balanced diet into their lifestyle at a young age. This way, the detrimental long-term effects of unhealthy eating doesn't set in. And here's a graphic that shows like the difference between healthy eating habits and bad eating habits and its relation to your health. There are several ways you can join the fight against food insecurity, such as volunteering at your local food pantry or food distribution site, donating to nearby organizations, educating others on the importance of a balanced and healthy diet, and working to destigmatize food insecurity and dismantle stereotypes about people who experience it. So over here, there's a picture of me at my church's food distribution site. And then this link, in high school, I was a part of a food insecurity public health club for teenagers in Raleigh. And for my capstone project, I created a website that housed a catalog of healthy meals that incorporated foods that were given out at my food distribution site so that families that came through would know or just have ideas of what they can do with the food that was being given out. And then in conclusion, food insecurity is an immense problem in North Carolina and across the nation. To remediate this issue, monumental changes must be made. Nutritional education programs are a great way to start. Informing food insecure communities about the importance of a healthy diet can help minimize their risk of developing chronic diet-related diseases. A statewide or a national program that incentivizes families to choose healthy food options instead of poor food options while simultaneously making healthy meals more accessible will also downtrend food insecurity and its detrimental effects. Access to adequate food should be a human right and not a privilege, but unfortunately, this is not the case. Hopefully, through public health education efforts and governmental program implementation, every American can have guaranteed food security in the future.
So my name is Faduma, and I will be doing a presentation on the larynx and vocal cords. So the larynx, usually you might have heard it be referred to as the voice box. It's a structure located inside of your neck that holds cartilage, muscles, and other tissues. The main function of it is to produce like sound for speech so that we're able to talk. So it's like the main organ that like allows us to be able to speak. It also regulates airflow, creates different pitches and volumes, and protects the airways from preventing foreign particles from entering our lungs. So the vocal cords are located within the larynx, and they're just flexible structures, also known as vocal cords, and they play a very major role in like speech production, sound, vocalizations. So the way that they work is that they vibrate, and everyone's like vocal cords and larynx are different. So they're all very like unique to us. And that's why like we all sound differently because we get different like sounds in different frequencies because of the way that our vocal cords adjust. But they also do more than just enable speech and allow us to talk. So when we cough, it's because foreign particles are inside of our airways. And so the vocal cords will be able to close to prevent them from coming through. And that's why we cough, because for like a brief moment, you're not really getting airflow through your vocal cords. And then swallowing as well, they close off the trachea, it's like the windpipe, to prevent food and liquids from entering the lungs when you swallow, so that your food isn't going to your lungs or places that your food and water and drinks are not supposed to go. And then breath control as well. So they're very relaxed when we are at rest, and they allow air to just flow in and out of our lungs. And then vocal quality, like I stated previously, vibrations create specific tones that are unique to everyone. And then sound is produced and then modified by the shape and size of the vocal tract. There's some applications in tissue engineering for vocal cords. Around 20 million Americans actually experience like speech impairments, but research and like solutions to that are very limited. There is a doctor, his name is Dr. Nathan Wellham at the University of Wisconsin-Madison, who's been doing some research on how to grow cells to repair damaged vocal cords so that people are still able to speak regularly. So they take these cells that are shown in these diagrams, they purify them and then grow them on 3D scaffolds. And then they develop features that are similar to human vocal folds, including layers within different characteristics. And then to determine whether or not the engineered tissue could transmit sound, they grew human-sized vocal folds, and they're able to like insert those into your vocal cords to be able to repair them, and then the cells will adapt to the existing already human vocal cord cells. And so then here's just some cellular composition of the vocal cords. The frequency, it's basically just made up of so there's like this membrane, lamina, propria, deep lamina, so just like layers, and then the extracellular composition, very similar to a lot of other structures inside like the throat and the mouth, lipids, lipid bilayers, carbohydrates, just hyaluronic acids, fibrous proteins, and then forces. So the vocal cords will go in the shear direction, so they'll go this way. They can also go just in shear, and then compress and decompress. So in conclusion, vocal cords are a very important part of sound production within the larynx. Speech modulation to protective functions like coughing and swallowing. Their versatility is very important in the way that we speak, talk, eat, and everything. Encompasses cartilages, muscles, and tissues, orchestrates breath control at rest, and contributes to the unique voice quality for every single individual person. And understanding the dynamic functions of vocal cords unveils their significance in both communication and respiratory protection. And the ongoing research in tissue engineering will be able to aid in so many million people in repairing vocal cords and their larynx and speech